Welcome back, dear guests, here at the Technical Forum on Hydrogen Fuel Cells Europe at the Hannover Messe 2023. Good to see so many of you here. It's getting busier and busier. I like to see it. And I understand it as well, because the talks are kind of interesting, and the next one is no exception. The topic, open automation solutions for the hydrogen industry. On stage from Phoenix Contact, the Business Development Manager for Power2X. Can I get a warm applause for Thomas Oesselke?
Many thanks for the introduction. So I can skip this one. Today I want to talk a little bit about open automation systems for the hydrogen industry. I will briefly introduce Phoenix Contact, our company, and then as a second point I will talk about the characteristics of open automation systems, what's so special about that. And finally, I do not want to dig into the too technical details, but I want to illustrate this in application examples, just to make it more practical for you. Some points about Phoenix Contact. Well, this year, also this Hanover show is a very special one for us, because this year we are celebrating our 100th birthday. We are a 3.6 billion euro turnover company with 22,000 employees worldwide, located in Germany and still family owned. And with our products from the electrification, automation and connection technology, we are serving all major markets, starting in the energy business, the infrastructure business and factory automation, but also especially the process technology. This is where we also allocate Power2X to. Our competence in this area, our competence for a carbon neutral future, originates from our company DNA. Actually, it all started with connectivity in 1923, and over the years, the product portfolio developed into the area of electrification, that means signal conditioning, power supplies, and finally also into the area of automation technology. And we do not only supply components in this area, but also services, for example, when it comes to consulting about functional safety issues, IT security, as well as intrinsic safety in this case. What is it now so important about? The core question nowadays is, I guess everybody of you will agree, we are living in very interesting times. Hydrogen is very rapidly evolving. However, also the requirements of our customers and the requirements of governments and regulations are rapidly evolving. And how can you cope with this rapidly evolving requirements? How can you ensure that your customer solutions maintain their functionality and availability? How can you meet new market requirements quickly, shorten your times to market, and especially, how do you react to constantly changing regulatory standards, to changing standard requirements? And when we have a look at the technical details, for example, based on a fuel cell application, some of you will recognize this picture, this structure. It's adapted from the IEC 62283-2. And of course, everybody will agree, the heart of a fuel cell application as well as the electrolyzer application, that's the electrochemistry, that's the stack in the middle. However, this has to be supported by lots of auxiliary functions like power conditioning, like water treatment, like ventilation, thermal management. So actually, next to the heart, you also need a brain, and this is typically the automation system. And this does not only cover the standard automation, you also have to deal with topics like safety and security. And of course, you can now have the ambition to develop also the automation solution on your own, to keep your IP internally. But on the other hand, you then run into troubles like time to market. How do you react to changing requirements? How do you react to the constantly growing demands concerning IT security, functional safety, and so on? So the other idea would then be, why not use an open automation system for that? And for this, of course, the question first is, what are the characteristics of an open automation system? First important point is, open automation systems avoid any kind of proprietary technology. They are completely based on open communication standards and open technologies. That also involves that they support, for example, open source apps and software, and that you as a user have the complete freedom of choice how you program these. Classically, PLC, you have the programming standards according IEC 61131, but today's programmers are more familiar with high-level language programming like Python, C#, C++. On the other hand, especially in the development phase, you also want to use technologies like model-based engineering, MATLAB Simulink, for example. An open automation system gives you the complete freedom of choice what to use here. You can choose your preferred engineering method, and you can also use this in parallel, actually. A further point, however, is you may have constantly growing requirements concerning functionality, concerning performance. That means open automation systems should also offer scalability when it comes to, for example, interfaces that are supported and the performance classes, the calculating power of the platform itself, so that you can start small, but you can upscale in the future, and you do not have to discard what you have developed for at the beginning. With all these topics in mind, we some years ago developed our open automation platform PLC Next, because our customers asked us for a more flexible approach. They wanted to maintain the benefits of the classical PLC that has a proven track record since decades in the industry, but they wanted to add the flexibility for Raspberry Pi. And so finally, the result is our PLC Next system, which is based, first of all, on a scalable portfolio of automation controllers where you can upscale the calculation power. This is then supported by a large portfolio of different I/O systems for standard applications, but also for applications in the functional safety range and in the intrinsically safe range. And it offers you complete flexibility concerning the engineering. That means you can use high-level programming like C#, C++, Python, but you can also treat this like a classical PLC, or you can use model-based approaches like, for example, MATLAB Simulink. And actually, around this technology, we have seen the evolution of a user community in the meantime. So there's also a very active user community that shares its knowledge, that shares its expertise via our PLC Next store, where you can find solutions most probably for your problems that somebody else already has developed. Let us have a look at some application examples. One topic, and we see here a growing demand from our customers, is the decentralized power generation based on fuel cells. Typically here we have applications in remote areas, off-grid, no service personnel on location. And on the one hand, of course, as an operator of these units, you have the requirement that the complete process is controlled. But on the other hand, you also want to ensure availability and maintainability, and not only with boots on the ground directly on location, but from the remote. As soon as people hear remote, as soon as they hear internet connectivity, some get a little bit nervous about IT security. And this again is the advantage of open automation systems like PLC Next. They have been developed according IT secure standards, according IEC 62243. So with the system, we enable cloud-based remote maintenance as well as cloud-based remote operation in this case. So you do not have to have somebody in location right up front, but you do a first diagnostics remotely. You can do software updates remotely in a secure way, and only if really hardware exchange is necessary or rewiring, then you have to set somebody in location. But based on the diagnostics, the guy already knows what he has to bring to the site, actually. Another use case is the use case, for example, of fuel cells in maritime applications. There we have a very dynamic situation concerning the regulatory requirements, especially when it comes to functional safety. However, with a modular system like ours, you can easily start with a certain setup you can also strictly separate the standard control from the safety control. And in case of future additional requirements, you just take your existing basis, extend it by the hardware, extend it by the software, and you are done. You have a safety investment right from the beginning in this case. Of course, this also applies to electrolysis applications where we have first pilot projects realized. And it was already mentioned in the presentation before, the big topic is integration. So all these assets are not working separate, isolated, but they have to be integrated to other assets. In the case of electrolyzers, they have to be integrated to renewable energy generation. They have to be integrated to grid connection points, to hydrogen storage. All different assets from different stakeholders, which somehow have to work together. And because of the open automation, because of the support of purely open standards, it's fairly easy for the system integrator to bring all the different assets, all the different stakeholders together. So to summarize this, open automation systems, on the one hand, reduce engineering times because you are basing your development on proven technology. On the other hand, they allow quick adaptation to changing market requirements. And they enable also the integration of different assets into hybrid applications. So finally, open automation systems make your application future-proof. If you want to learn more about this, we are happy to support you and to talk to you at our booth here in hall number 13. You find us at 334, and also at our main booth in hall number 9, F40. And please do not hesitate to contact me also via LinkedIn. So we are happy to assist you with your applications. Many thanks.
Thank you, and a warm applause.